Hi everybody, in this video I would like to show you a connection between the answer or a solution for a quadratic equation that you can see on your screen, or as a matter of fact any other quadratic equation you are solving, to the graph of that equation. I'm going to use the TI-84 graphing calculator to help me out here, and I'm going to show you the connection between these 5 keywords that you see on the screen right below your solution of the equation. So x equals to 5, x equals to -1 is the solution, which is done by factoring. We have factoring. If you forgot, it's in a unit 3. You can go back and see how you can solve equations using quadratic equations using factoring. And this is an example of that solution when the trinomial is broken down into 2 binomials, for which it's much easier to guess when is this binomial equal to 0. Of course, when x is 5, 5 minus 5 is 0. When this binomial is equal to 0, of course, when x is equal to -1, -1 plus 1 does equal to 0. So it's like a brief review of how to do the solving quadratic equations using factoring. Now, so this isn't the answers, they are the solutions of the quadratic equation. Why are there answers or solutions? Because if we substitute the values, they're gonna work. This is really gonna turn into 0. Let's quickly check. X equals to 5. 5 squared is 25. 5 times 4 is 20. 5 minus 20 is 5. 5 minus 5 is 0. So it works. It is an answer. It is a solution. Not just simply answer or a solution, it's such an important answer or a solution that it's actually called root, or there are 2 of them, so therefore they're roots. The answers to equations are very, very important for many applications of algebra, so that's why the word root means something important, right? What's the root of this? The root of this means it's the most important thing of whatever matter you have. And x equals 5, x equals -1 are also called roots because they are important answers, important solutions. Now, why are they called zeros? They're called zeros because the quadratic equation are equal to 0 and they turn the value of the trinomial or each of those 2 binomials into 0 when you substitute it. Like we said, 5 minus 5 turns it into 0. -1 plus 1 turns it into 0. So those are also called zeros. Okay, so these 4 keywords are pretty much clear. Now I'm gonna just sit a little bit longer and explain a little bit more about the last term of x-intercept. Why are they called x-intercepts? Well, that will help if we will graph them, and let's try to do that. So first of all, turn on your calculator, and I am already there. Go to the y equals screen. We're going to enter x squared minus 4x minus 5. X squared, wrong button, square is right here. X squared minus 4x minus 5. Now we're not going to enter equal to 0 here because we just can't. The calculator doesn't let us. So instead, we're going to specifically say that it's not for any y that we want to find out the answer, but for the y equal to 0. So we're going to press enter, and we're going to put one more condition on the calculator, that we want this equation to be solved when the y value is equal to 0. So there are 2 things you'll have to enter: the left side of the equation and the right side of the equation. Of course, it's equals to 0, so the right side of the equation is 0, so that's what we have. Now, let me just graph it, and in order to graph it in a nice window, I recommend that we first check if the standard window works. At Zoom 6, Zoom standard should show you graph in a nice -10, +10, x and y values window. Okay, so we have our parabola in a U shape, and we have 2 points where the parabola crosses the x-axis. You see those points? This point right here. If you eyeball this point, what's the value? Well, it's 1. Looks like it's 1 unit to the left of the 0. So I do guess that that's my -1. What's my -1? Well, it's one of the answers, right? Let me see how many units is the second one. It's 1, 2, 3, 4, 5. I'm sure you predicted that. X equals to 5 is my second answer. So that's the x-axis. Each value on the x-axis, each y value, pardon me, of the x-axis is equal to 0. So this is the y equal to 0, x equals to -1. Y equal to 0, x equals to 5. And this is where the graph intersects the x-axis. So this is x-intercept. Okay, those are the solutions, answers, roots, zeros, and x-intercepts. See why they're called x-intercepts? Because when you graph your parabola, when you graph your quadratic equation, it will cross the x-axis at those exact same places where you have your answers for the equation. So it's like an alternative way of solving a quadratic equation, if of course we are lucky enough and the places of intersections are exact. They're not always exact, but in this case they are. We also want to see the way the calculator shows us those values. That would be nice. Just double check, right? I don't want to always estimate and look at it and see, oh, it looks like the answer is -1. I want to know for sure, okay? So that is the feature on this calculator which we can easily work with. So you're going to do second place press and trace, which gets us into a calc menu. Now in the calc menu we have so many different options. Value 0. Oh, 0 is one of our terms here. Yes, you can use the second one. But I want to use the number 5, not the last one. Number 5, because it's like easier to get, less buttons you'll have to press to actually get to the end of it. So I'm going to use the 5th feature to show you the intersect. Now the calculator starts to ask you questions. What if you have 5 graphs and not just one, right? So it asks you, is that your first curve? Well, this is our first curve. That's what we have typed in y equals window first. So you'll say enter. Enter means yes, okay? Now remember we put the 0 for the y2. They're asking you, is your second curve? It's not really a curve, it's a straight line. It's the x-axis. They are looking for the points of intersection of the graph with the x-axis, right? But it's okay, we still answer a yes. And then we're asking you for the guess. Now for the guess we're gonna try to go to the left as close as possible to our point of intersection. So it's somewhere here, I believe. It doesn't say -1, it says something else. But when I press enter, I actually will be now seeing the correct answer is here. We were right all along. X equals to -1 is the intersection of the parabola with the x-axis. So that's one of our answer solutions, roots, zeros, or x-intercepts. It's right here, and it's x equals to -1. I want to see the other one, right? So we have to do this all over again. We're going to press second, I'm going to press trace, get into the calc. I want the intersection of the graph with the x-axis. So I'm going to press again, choice 5. First curve, yes. Second curve, yes. The only thing that's going to be different, of course, is our guess. So I'm going to press arrow to the right until I get to my other point of intersection somewhere here, I'm guessing. And then when you press enter, whatever we expected, we can now see on the screen. Yes, it worked. X equals 5 is our second x-intercept. It's our second zero-root solution or answer. So please keep in mind, every time when you see one of those keywords, in your problem solving. That means that they are asking you either do it by factoring, as you already learned, or they might just show you the graph without giving you the equation. But you will know that those are the 2 points that will be your answer solutions, root zeros, or x-intercept. Okay, so then once again, there are many ways to do it. It's by graphing, it could be done by factoring. There are other ways we will learn in the next more advanced algebra. And I'm going to end this video here. I hope it was helpful, and I'll see you soon.